Welcome. This is Marwa Hasni, Assistant Professor in Industrial Engineering, and I'm about to present a research work titled A New DEA-Based Approach to Assessing the Performance of Learning Processes Within Teaching Hospitals. This is a joint work with Ma'am Najla Isawi Omran, Ma'am Safi Bhar Laib, and Ayman Mannai. Our presentation agenda is mainly tightened up upon 5 parts. After deploying our motivation behind our work, I will explicit the research questions we've got interested in. Our academic contribution is then outlined, followed by an empirical investigation to put evidence on its performances. This presentation ends up with concluding remarks and suggestions for further research, so let's get started. As may be guessed, our work context is healthcare, which remains a crucial and challenging endeavor to undertake for many countries. This is because it helps for economic growth, but also because many of people's aspirations cannot be met without healthier lives. For that purpose, healthcare providers typically get interested in evaluating healthcare systems to help to retrieve uplifting directions. In the academic literature, efficient body-based methods are commonly used. These methods could be either parametric or non-parametric. Methods allied to the parametric approach could be the stochastic, the free distribution, and the thick frontier approach, whereas the data envelopment analysis, the free disposal whole approach, and the Malmquist productivity index are relevant examples for non-parametric approach. Among these methods, the data envelopment analysis variant reveals the mostly used for the comparison of the relative performances of different hospitals and for the performance evaluation of health units within the same hospital. Here, we shall point out that most studies define the hospital as a decision-making unit, DMU, rather than a healthcare unit. A key aspect of the data envelopment analysis approach is that it distinguishes between efficient and non-efficient healthcare units by measuring their dissimilarities. This analysis is typically carried out at a highly disaggregated level of data that includes a high number of features to consider. Though being accurate, the data envelopment analysis focuses on the efficiency measurement of DMUs and fails to provide deep insights on the best use of the underlying resources. This may be explained by the fact that data envelopment analysis is a distance-based clustering approach that only provides information on the dissimilarities between DMUs. So to undertake the shortage, an available scope in the academic literature suggests making use of the production function theory when clustering healthcare units instead of using a distance function. In this context, we got inspired by this idea to develop and introduce a data envelopment analysis algorithm that employs a production function-based procedure for clustering. Evidence on the performances of our proposed method is shown through an empirical comparative study. To start with, let us first recall the data envelopment analysis principle in order to highlight its shortage. Let a number of DMUs be the units to be analyzed, whereby each one of them is characterized by a feature vector, say xi and yi. Using the basic data envelopment analysis method, a number of clusters are mapped out whereby each one of them encompasses similar DMUs. As previously mentioned, this similarity is modeled by means of a distance-based function, say d, that measures the discrepancy between each feature and the cluster center Cj. As such, if a DMU belongs to a particular class, this means that the total dissimilarities between all underlying features and the class center and the concern is minimal compared to those of the remaining classes. This corresponds to the following objective function. This objective is to be minimized under two constraints, whereby the first ensures the linear relationship between inputs and outputs, and the second constrains the outputs to be equal to 1 for each case. This is an input-based data envelopment analysis variant which could be used to minimize the use of inputs to obtain a given output. If we refer back to the first constraint, we can notice the use of the inequality formula of production function. This highlights the implicit property of data envelopment analysis, which consists of employing production functions to transform multiple inputs into outputs. And this triggers the idea to further make use of this theory for the clustering task of data envelopment analysis. In fact, solving this linear program would yield the optimal virtual multipliers U and V, characterizing all possible production functions which would serve as piecewise frontiers to classify the available DMUs. Henceforth, we can introduce our proposed approach according to the following steps. First, we have to run the data envelopment analysis model to obtain optimal virtual multipliers U star and V star. This would allow retrieving the production function corresponding to each DMU. Here, we shall only consider production functions of efficient DMUs as they give information on the optimal amount of input resources that are required for benchmarking. Afterwards, we advocate verifying whether the selected production function encompasses at least one null virtual multiplier or else whether the inputs are equal to the outputs. In this case, we have to dismiss these DMUs as they could not serve as references. The next step consists in evaluating DMU's efficiencies according to the remaining retained production functions in order to obtain the optimal DMU's clusters. Indeed, DMUs within one homogeneous cluster necessarily present the higher efficiency when confronted to a particular production function. Now that our approach is presented, we attempt to assess its performances by means of an empirical comparative study. For this purpose, we got interested in the evaluation of the learning process of Charles University Hospital, which is one of the sizable multi-specialty teaching hospitals in Tunisia. Going into more details, empirical data consists of 25 DMUs, which correspond to the care units learners are accommodated in. Each DMU is described by a threefold feature, namely 2 inputs and 1 output. Indeed, we are concerned with the determination of the optimal number of physicians, X1, and supervisors, X2, that are required for optimal teaching expertise of students, Y1. In particular, we aim at identifying the minimal number of teachers to maintain given the flagrant brain drain phenomena obviously observed during the last years. So after collecting the corresponding data, we run the data envelopment analysis model to obtain optimal virtual multipliers. These results are developed in the following table. As may be noticed, the dentistry, the gynecology B, and the pediatric are efficient DMUs. By selecting their respective virtual multipliers, 2 frontier production functions are obtained, mainly the PF1 and PF2. In addition, we notice the existence of 8 degenerative DMUs as they present at least one null virtual multiplier. These DMUs will be classified into the nearest frontiers that they confront. For cluster 1, both DMU7 and DMU15 are efficient, and hence the remaining units could follow their patterns to empower their performances. Similarly, DMU25 plays the role of the benchmark unit to be followed for cluster 2. As may be noticed, our proposed approach provides a two-level clustering of DMUs, whereby the first is given by the production function that the evaluated DMU confronts, and the second is according to the efficient ratio that allows distinguishing between highly and poorly performing DMUs. Consequently, a comprehensive analysis on the relative performances between DMUs is obtained and helps to develop secure directions for improvements. To put evidence on the accuracy of our proposed clustering-based data envelopment analysis, we shall compare it against its apparent counterpart. To this end, we conduct a similar evaluation of the learning process using the data envelopment analysis tool and visualize the way the DMUs could be arranged. These results are given in the following table. Accordingly, we can notice that the data envelopment analysis suggests 3 clusters instead of 2. Besides, we notice unstable division among DMUs. For example, according to the distance-based DMU 4 and 11, they could be arranged into groups 1 or 2, so we are not sure about their suitable class and whether they are similar or not, which might be confusing for managerial directions. Meanwhile, these DMUs belong to the same cluster, C1, when using the production function clustering-based methodology that we propose. As such, more stable and reliable results could be retrieved using the production function envelopes. In this study, we investigate the production function theory to propose a production function clustering-based data envelopment analysis. The objective is to show that when taking into account the relation between inputs and outputs for data clustering, more meaningful classification and stable clusters could be obtained. Evidence on the outperformance of our proposed approach is outlined by means of a real case study assessing the performances of 25 DMUs in a public Tunisian multi-specialty teaching hospital, and comparing it against that yielded by the distance clustering-based data envelopment analysis. Here, we point out that these results are obtained under particular assumptions on the data model, namely, it's an input-based objective that we simulated under a constant return to scale. For that, further research would investigate the generalizability of the advantages of the production function clustering by simulating other data envelopment analysis variants, as well as other case-based DMUs. Thanks for your attention. Your questions and comments are welcomed.